Hello and welcome to another exciting chemistry session. This is your host, Mr. Matza. So as of today, we're going to look at the writing of chemical formulas involving transition metals or transition elements. So we're going to look at the chemical formulas that involve transition elements. So what are transition elements? So just to give a brief background about transition elements. When we go to the periodic table, we have this long stretch. Don't mind my periodic table drawing, it's not straight. So we have this long stretch between group 3, group 3 and group 2. So we have group 3 and group 2. So the stretch between group 2 and group 3 comprise of what we call transition. So they are called transition elements or transition metals. So these are special elements in the manner that they do not have a fixed valence number. They do not have a fixed valence number. So when we check for these other elements on the periodic table, they have a fixed valence number. For group 2, we said this is 2. For group 3, we said it's 3. Group 4, it's 4. Group 5, it's 3. Then 2. Then 1. Then you have group 1, 1. But for these, they do not have a fixed valency number. They have what we call variable valence numbers. Their valence numbers are not fixed. They keep on changing. Now, that is a story for another day. Now, our interest here is when we are writing chemical formulas that involve transition elements, the valence number is specified in brackets. So we're going to find A is the name of an element, then we're going to have a valence number, so specified in brackets, written in Roman numerals, then we have B. So this simply means that this is the valence number for A. This is the valence number for A. Let's get back to the notes so that we get more details. So the valence number of transition elements is variable. Meaning it's not permanent, it keeps on changing. And the valence number of transition metals is written in Roman numerals and enclosed in brackets. We have an example right here. So zinc 2 chloride. So the meaning of a 2 there is the valence number of zinc. So when you are writing the formula, as you can see from this step, they have put it 2 here to say that the valence number of zinc is 2. What is the valence number of chlorine? It's 1. So when we interchange, we get zinc chloride. So zinc 2 chloride. So this would be called zinc 2 chloride. Zinc 2 chloride. We have iron 3 oxide. So meaning the valence number of iron is 3. So what is iron? Iron is Fe. So Fe, the valence number is 3. Then oxygen, the valence number is 2. So when we interchange, we have So this is called iron 3 oxide. Iron 3 oxide. So there are a lot of formulas that involve transition metals. There are a lot of formulas that involve transition metals. What is important is to identify the valency number, which is always written in Roman numerals and enclosed in brackets. So there are so many formulas. I can give you some examples that you can practice on. So you can just try to pause the video and see if you can answer. So write the chemical formula of each following. One, the iron 2 chloride. Chloride. 2, the copper. 1 oxide. 3, the zinc 2 sulfate. 4, the lead nitrate. So you can pause the video and see if you can write the chemical formulas of each of those compounds involving transition metals. So the following are the expected answers. So the following are the expected answers. So this is Fe, FeCl2. This is Cu2O. Then this will be Zn, ZnSO4, that is zinc sulfate, sulfate. So lead is Pb. So Pb nitrate, remember, is radical. So NO3, NO3, 2. So those are the expected responses to those questions. If there are any pressing questions, feel free to put them in the comment section down below. So we have come to the end of this episode. Bye bye.